the sun. Are you frightened of it? Here at the Smash News Network, least busted name in news. We certainly hope not. Here's some imagery of it of the past day. We show it daily in great detail here at the Daily Space Weather. Congratulations on realizing our channel exists. This is composite imagery from the Solar Dynamics Observatory. Ionized iron and ionized helium. We're going to be focusing mainly on the northern hemisphere of the closest star. There is a coronal mass ejection warning back in place. We expect another coronal mass ejection propagating soon. I would note Sunspot 2882 in the lower right of your screen down here. It's the main feature on the Earth-facing portion of the solar disk. Now, we've brought up the last week of colorized magnetometer. I just want to show you the progression of the magnetic fields. And those of you out there who are regular viewers, you're well aware that magnetic fields are largely in charge of the solar cycles and most of the activity, whether it's coronal holes or sunspots. You can see this South Pole umbra oddly lurking around into the front of that sunspot. That doesn't mean it's a new solar cycle, folks. There are oddities and a lot of chaos going on around the surface of the closest star. Solar flare watch remains in effect. Solar flare warning remains in effect, actually, as a result of the complexity of Sunspot 2882. Did you know the sun emits radio frequency of the 10.7 centimeter radio flux variety? It comes out of the upper chromosphere and lower corona, and it's the most proportional data set we have to sunspot number, discovered in 1947. The 10.7 centimeter radio flux, there it is over the past year. The black line there is the radio flux. It's down to 84, as we see no other sunspot groups besides 2882. NOAA forecast does not include any geomagnetic storms or unrest. Yesterday we saw about 6 hours of a G2 class geomagnetic storm, a KP6 event. Let's take a look at global seismicity real quick. The largest quake of the past 24 was this 6.4 at Greece. Besides that, no other major quakes over a 4 magnitude. There was a deep one at the Fiji Islands at over 513 estimated kilometers depth. A 4.5 magnitude, that quake. Also, Papua New Guinea saw a deep quake at a 4.9 magnitude. Dominica saw a small 3.9 at depth. So some quakes in the Caribbean there, including also Puerto Rico. Shout out to our viewers viewing from the Caribbean. Tonga and Japan also saw deep quakes. Those were both low 4 magnitude quakes. Continuing on to volcanoes, Cumbre Vieja continues to erupt. And here's some great satellite imagery. You can find this yourself on scitechdaily.com. Here's the article. A new lava river has formed and been captured by the satellite. So there's a great image of it to give you a little bit of a geographical perspective. We'll just let the article scroll here in case you'd like to pause and read. Don't worry, folks. When you unpause, we'll be here when you come back. There you can see some ash, it looks like. Also gases and aerosols showing up in that imagery. SciTechDaily.com. So let's see what else is erupting here. Of course, La Palma, Cumbre Vieja. Calming down a little bit here as far as the size of the ash plume. Once again, down to 7,000 foot ash plume there. It's still exploding. Please don't pole vault the caldera. Suwanosejima in the Ryukyu Island, 6,000 foot ash plume there. Semeru on East Java, 14,000 foot ash plume as it explodes. Popocatépetl, which is on my bucket list, by the way. No volcanic ash observed in satellite imagery. Fuego, producing a 15,000 foot explosively over Guatemala. Nevado del Ruiz, exploding, 20,000 foot ash plume over Colombia. Sangay, 20,000-foot ash plume over Ecuador. Revenador exploding, 15,000-foot ash plume over that same country, Ecuador. Sabancaya exploding, 25,000-foot ash plume. And Novatos de Chilean exploding. Intermittent volcanic ash emissions are enough to produce a 13,000-foot plume of volcanic ash. Don't pole vault that caldera either. Do visit our links, support our channel, as we're tanking over here, and one of the ways you can help us out would be to pick up some merch. Maybe you'd like to pick up our bestseller, which is, these are actually in the order of best-selling. My vaccination status is none of your business. Did you know that those not responsible for your health care and the administration thereof have no legal right to any of your protected health information? I'm wearing one today. It's in orange. The Health Insurance Portability and Accountability Act of 1996, known as HIPAA, is designed to, well, it's designed to do a lot of things. I won't get deep into it, but your protected health information is yours and yours alone. So visit the links. There's the shirt I'm wearing. It's in orange because nothing says don't run me over or shoot me like an orange piece of clothing. Welcome to the Neo Renaissance. Thanks to our smAsh team members for making these videos continue to exist, remain publicly visible, and free for all to view. This is smAshomash.com, by the way. Look for changes coming soon to the homepage. smAshomash.com. You can find all of our links there. And we were just at the smAsho merch link. That links you to our Redbubble shop. The print quality is spectacular. So help us out that way if you're in the market for some gear. Also help your friends and foes to understand reality by providing public service messages on your clothing. Next, the GOES magnetometer here, and you can see all these spiky readings. There was a lot of plasma arriving yesterday as a result of a coronal mass ejection. It would be no surprise to our regular viewers. Congratulations once again on realizing our channel exists. Let's take a look at the heliospheric current sheet, and I think there's going to be some sunspot activity in the southern hemisphere. We have a North Pole bit of current sheet showing up right here. And Earth could be in the process of snapping into that as we speak. We do see a divergence here. We see the GOES 16 and 17 showing different readings here just in the past half an hour, actually. And the likelihood of some sunspot or something like that. A sunspot in the southern hemisphere. That's my forecast. We don't usually try to forecast sunspots as they form rather spontaneously, but nonetheless, I'll take a chance. Anyway, here's the line of sight ecliptic plane field plot. And most importantly, here's the line of sight coronal hole plot. We see some well-defined coronal holes here. We'll show you additional imagery of that as well. And that South Pole coronal hole there shown in red at the left is transequatorial. We'll see how well defined that remains when it rotates closer to Earth. So we see two significantly well-defined coronal holes here. This one down here, which is North Pole oriented, so transequatorial coronal hole there. And this one up here is also North Pole. So we've got North Pole coronal holes facing the Earth here. We can expect a high-speed wind from this one in about 3 days. And this one in about 4 days, if it stays as well-defined as it is. The Integrated Space Weather Analysis Center, by the way, on page 1, you can monitor this yourself if you like. The Solar Flare Probability Monitor and Detected Sunspot Groups. It's right on page 1 of the Solar tab. It's the default page 1 view of the Integrated Space Weather Analysis Center. And a solar flare warning remains in effect as a result of the size and complexity of sunspot 2882, which remains a beta-gamma class, kind of a weird sunspot as it has a South Pole leading umbra. Continuing on to look at flares. And only one tiny C-class flare here over the past 3 days, actually. Again, solar flare warning remains in effect. No spikes in the proton flux. The relativistic particles sent to Earth from that M-class flare that caused yesterday's coronal mass ejection geomagnetic storm have completely subsided, and we're back to a baseline of proton flux. How about the real-time solar wind? It's fairly unremarkable over the past, especially the past 12 hours. The solar storm has subsided. Current conditions are only 3.5 protons per cubic centimeter for the solar wind density, solar wind speed 437 kilometers per second. And we've got a steady BTBZ and just unremarkable solar wind over the past 12 hours. There's the KP index, a measurement of global geomagnetism, and you can see that geomagnetic storm there shown by the red bars. So there were about 9 hours of geomagnetic storm conditions and another 9 hours of geomagnetic unrest there, each bar representing 3 hours. Let's take a look at the geospace modeled by the Space Weather Modeling Framework. Magnetohydrodynamic pressure, aka nanopascals, over the past 4 hours. And we see a homogeneous pressure around the planet. Plasmasphere looking pretty normal, really. Don't worry, folks. The sun's not going to kill you. Next, ground magnetic perturbations, looking at changes to Earth's own B field. We showed you the sun's B field. Here's the Earth's, or at least changes in it. Now we're looking at magnetic flux density, though, in nanotesla, not magnetohydrodynamic pressure. It's still 4 hours of data, and we saw massive magnetic pulses yesterday during the geomagnetic storm. Watch yesterday's video. We'll show, you can see 4 hours of that as well. We show these two panes daily on the Daily Space Weather. We want our viewers to be immersed in facts and be able to understand how the different variables relate. Speaking of how things relate, here's what's going on in the solar system. Mars is looking lonely. Let's advance this 1 week. And there's where things will be in a week. It looks like a full moon coming on the 20th. Next, a star chart. There's the path the sun will take across the sky in the form of the ecliptic line, which is the yellow line. The galactic plane is the blue line. And where were you when Cygnus rose? Let's do a cosmology segment. This one will be integrated into the Daily Space Weather video. Keep in mind, we've got over 200 cosmology segments in our cosmology segment playlist. Go check it out, youtube.com/smashamash/playlists. There was a major survey done which turned up 461 new objects, but no Nibiru. Sorry, cosmology noobs. There's no Nibiru out there. There are 461 new objects discovered, but no Nibiru. Darn. The Dark Energy Survey. You may never understand the power of the dark energy, or the lack thereof. There's a lot of missing matter out there, folks. And I'm just going to leave it at that. That's an artist's rendition, by the way, not a photograph. So you may want to read that article, another one from SciTech Daily. Scratch that. We're picking a random number. It's number 95, which coincides with a radio quasar. Yeah, it's a radio quasar. It's showing up in all kinds of portions of the electromagnetic spectrum. Here's PKS 0244. That's entry number 95 at the Neil Gehrels Swift Bat X-ray Observatory. Yeah, it's a radio galaxy that's also a quasar. So this one shows up in different portions of the electromagnetic spectrum. We'll show you in a minute. These are the hard X-rays from it. And you can see it's not a super consistent hard X-ray source. It's fairly diffuse in its X-ray output, but it's quite interesting in radio. So here it is on the CDS portal. And you can see it as a very bright radio source, not a particularly common feature when it comes to quasars. And I'm just going to scroll up the bands here and just show you some additional wavelengths. This particular view is 170 to 231 megahertz, a portion of the radio bandwidth. Now we're in gigahertz. Now we're back to megahertz. There's an interesting view here, 843 megahertz, showing a very bright signature there from that radio quasar. Perhaps a small satellite galaxy here in the foreground. And maybe that's why it's showing up in radio, because there's a plasma jet in between that galaxy and its satellite galaxy. That would be an appropriate explanation for why we see two bright radio sources there. Let's continue on and look at some more traditional wavelengths here that we show regularly on our cosmology segments. Here's the infrared spectra from it, and it looks completely dark there in infrared. A tiny signature showing up. And here it is on the DSS-2, that's optical wavelength. Here's ultraviolet, and you do see a signature from that as well. That's today's, quote, random, end quote, object. Again, it's number 95 at the Neil Gehrels, PKS 0244-470. And you can see the way, when you look at the photometric points here, that there's some missing bandwidth here, but it shows up in things like X-ray and then in radio, but less so in the middle portion of the frequencies like optical and so on. Today's astronomy picture of the day is showing you 3 different chemical components here of a large nebula. This is I think this is 40. So this is located at 3,000 light years distance, and the field of view here is 40 light years. So this giant nebula here, this is known as NGC 7822 from the New General Catalog. And what you're looking at there is that's oxygen, hydrogen, and sulfur in blue, green, and red. Oxygen, hydrogen, and sulfur in blue, green, and red. So showing a little bit of chemical complexity there. You can see there's sulfur around the center of that, and sort of in these intra-shell regions. Anyway, that's the astronomy picture of the day, taken from a small telescope in Texas. You can go look at it yourself at apod.nasa.gov. How about a strange radio signal coming from around the core of the Milky Way Galaxy? Yeah, the core of the Milky Way Galaxy, like the sun's not going to kill you. But there's an article about this radio source, and it's not understood what causes it. So this is a special type of a transient radio event here. It's known as J173608.2-321635, which is named for the location of the origination of that radio source. Here's Ziteng Wang, who is involved in the analysis of this and so on. And here is Tara Murphy. And again, it is not understood the type of cosmic object that can cause a radio source like this. And so it's anybody's guess. Discovered by the Parkes Radio Telescope. That's another article from SciTech Daily. It's a big day for SciTech Daily's articles. That's today's cosmology segment. Again, check our playlist, youtube.com/smashamash/playlists. We do all kinds of stuff besides daily space weather, so check it out. Next, looking at things like electron flux and charging hazards. We don't see any charging hazards. We do see some anomalies in the electron flux. We'll get to it. Here's a one-year chart of the relativistic electrons. That's from solon.info. And here's a 3-day chart. We can expect to see some electron warnings coming in the next couple of days here following that solar storm. You can see NOAA forecasting higher levels here. I would tend to agree with that. That forecast right there is nothing that I'll argue with. Here's a diagram of Earth's Van Allen belts. Feel free to pause the video. Distance is shown in miles. And we see some major electron anomalies here over the Central Pacific Ocean. You're going to see very high levels of electron flux right over here. That's a little bit anomalous there. Besides that, everything looking normal with the total electron content And this helps with the prediction of GPS errors and so on. If you're around the equator at noon, your GPS could be off by thousands of miles. Don't let it ruin your day with the total electron content forecast. So here is the diagram of the atmosphere. We show this daily as well to show you where the F-ionosphere layer is. In many ways, the bridge between Earth and space at about 300 kilometers of altitude. And here's the ionogram. Looks like we're seeing some additional high and low frequency anomalies once again. Major high frequency anomalies there over the central Atlantic and over South America. Anyway, here's the latest image. That's 9:15 Universal Time. Here's the anomalygram. This is departure from the 30-day median in megahertz. You can see low frequency anomalies here in the Northern Hemisphere. Primarily, major ones there up around the North Pole, actually. And around Northern Europe and Greenland and the North Atlantic. High frequency anomalies in between there and the equator mainly. And here's the latest image. That's 9:30. So there's 9:15 there and 9:30 there. Have you seen our meteorology segments? Well, if not, check them out. There's a playlist for that too. And we've streamed yet another great meteorology segment, twitch.tv/smAsho. It'll also be on BitChute. Here come our bonus features. So once again, we've reestablished our coronal mass ejection warning today. There are a lot of filaments, and some of them are going to be leaving the solar corona soon. How we're able to forecast that, I can't tell you yet. That information's coming soon as well. Sunspot 2882, the main feature here. You can see filaments all around. Some down here mainly. Also filaments up here. You can see filaments, prominences there overlapping the edge of the solar disk. Our next bonus feature is the solar intensitygram. Is there a sunspot forming in the southern hemisphere? I don't see one yet. Here's Sunspot 2882. And I think this is actually another sunspot here, folks. This is actually another group. So that's probably going to get a name as well. Again, the likelihood of major solar flare is still quite high with the magnetic field complexity of Sunspot 2882. There it is. And it looks like the leading umbrae might actually be breaking down, but I would still say coronal mass ejection warning and solar flare warning in effect. So we'll close out with some more imagery here of 2882. This is 94 and 131 angstroms, which are two of the best views to view solar flares, the best wavelengths. And we'll close out the video here with 304 and 171 angstroms. Once again, thanks for tuning in, folks. Shout out to Tamitha Scove. And may that solar wind be at your back.